So you should have space to add this example 5, maybe in the column of page 201, or maybe you have room at the page, at the bottom of page 200. So example 5, what we're going to do here is we are going to look at a question that says graph. And the reason I'm adding this example is all the examples we've done so far have provided us with a graph. So they're a little bit easier. Now we're going to look at, could we do this with one of our parent functions? So we're going to take and graph y equals 3, and then brackets negative 1/2 x to the power 3. So first thing you'd have to do is think of the 4 graphs that we did on that Friday. Which is the parent graph for this one? Yeah. So we need to recognize out of that whole thing that this is a cubic graph, and our parent graph is y equals x cubed. So what we do is we see that, and then right away we do a quick sketch of our parent graph. We know points on that graph: 0, 0, 1, 1, 2, 8, negative 1, negative 1, and negative 2, 8. Yes, the bracket didn't close. Then we're going to look at our equation and say, what's different? What's different from our parent graph and the equation that we have? Well, there's a 3 in front, and there's a negative inside the brackets, and there's a half inside the brackets. Those are the things that are different from our parent graph. So now we just do a quick explanation of what each of these things are going to do. The 3, what's that going to affect? Y coordinates or x coordinates? Is it going to be vertical or horizontal? It's going to affect y. So this would multiply, this would be a vertical stretch. And if we want to put it in brackets, what's going to happen is your y values are going to multiply by 3. The negative 1/2, that's going to affect the x because it's inside. Okay? The negative is a reflection. And what will the half do? It'll be a horizontal stretch by 2. So we're going to, which axes do we reflect over if the negative's there? Okay? It's affecting the x. You're going to be tempted to say the x-axis because it affects the x. But think about an x point, and think about that x point becoming negative. Which axis is it going over? It's going over the y-axis. So we have a reflection over the y-axis and a horizontal stretch. I'll put in brackets here what's going to happen. Oops, not y. X by, and you can put both of those together by writing negative 2. So the negative does the reflection, and then because it's a half, we would have to multiply by 2. Now this is just good practice to help you think about what's happening beforehand. Okay? This, what I wrote under each thing, you may want to do. You might get short forms and call vertical stretches VS's and horizontal stretch HS, stuff like that, so it doesn't take as much to write. What you would need to show as far as your work is, now I'm going to take my 5 points, 2, 8, 1, 1, 0, 0, negative 1, negative 1, and negative 2, negative 8. to draw arrows for the transformations of each of these. And above here, this is where I'm going to write y by 3, x by negative 2. And say, where does that go? X by negative 2, negative 4, 24. Negative 2, 3. This one's going to stay at 0, 0. 2 comma negative 3 and 4 comma negative 24. I like to graph them on a new separate graph just because it keeps your notes cleaner. Now we can label these new points 0, 0, negative 2 comma 3, and I think the other point will be too far off the graph, probably somewhere way up there if I had to graph, negative 4, 24. So I'm going to just label these 3. 2, negative 3. And draw my new graph. Think about your original graph. Does it look like it's been flipped? Does it look like it's been flipped over the y-axis? Yes. And it has been stretched. You still have the same general shape that your original graph had. And so you will get some questions like this where you have to recognize the parent graph and then be able to do the transformations.